Now, one question. Show that integral sine square x dx is equal to x by 2 minus sine 2x divided by 4 plus c. So you have to show that this left hand side is equal to the right hand side. Means you have to find the integral of this guy, and the answer should be like this. We know from the formula that integral sine nx dx is equal to something, and that something was the reduction formula, and the reduction formula says that it will be minus 1 over n cos sine n minus 1x dx plus n minus 1 over n integral sine n minus 2x dx. So we have already this theorem, and this is called the reduction formula for the sine x. So whenever we have something integral in the form of sine x, we can do it, unless the condition is that the power should be either 2 or greater than 2. For single sine x, you don't need to apply the reduction formula. Even if you apply, it will give you the same answer, because for single sine x, you know that the answer is cos x. So you can try for taking simple sine x and use the reduction formula to solve this integral. Means the value of n is 1. So when you put the value of n 1 here in this formula, you will get the answer, and the answer will be minus cos x. Anyways, here we are doing the sine square x. So it means this is exactly same like this. Only the difference is instead of n we have 2. It means n is equal to 2. So in this whole formula, replace the guys with 2. When you replace the n on the left hand side, it becomes sine square x dx in the reduction formula. And on the right hand side, minus 1 divided by 2 cos x sine raised to the power 2 minus 1. It will become 1, so sine x plus n minus 1 means 2 minus 1 divided by 2. So it will be 1 by 2 integral sine raised to the power n minus 2 means 2 minus 2 because n is 2. So it will become sine raised to the power 0 x and a dx. So this is minus 1 by 2 sine x cos x plus 1 by 2. When something has a power 0, it is equal to 1. So this expression becomes 1, so it is integral of dx. And when you solve the integral, it becomes minus 1 by 2 sine x cos x plus 1 by 2 x plus constant of integration. Now this guy is a half angle inequality in terms of the trigonometry, and you always know that sine 2x is equal to this expression sine x cos x is equal to sine 2x divided by 2. So when you put this into this expression, sine x cos x is equal to half angle inequality, it becomes minus sine 2x divided by this 2 into this 2, it becomes 4 plus x by 2 plus c, which is the right hand side. Okay.
Yes.
Similarly, if you have the same integral but in terms of cos, then you can try to solve it in putting n is equal to 2 into the cos reduction formula, and you will get the answer. Wherever you go, if you don't know the, like, for example, here we use the half angle inequality, half angle formula. If you don't know, you don't need to apply it, you can leave there, because the only concern of solving the integral is that you have to find an expression without integral. Now if you are unable to simplify it, no need, no problem, but there should not be an integral in any of the expressions on the right hand side. That is the job of solving an integral. So you finished already the cos reduction formula? Yes or no?
Just one step. Just one or two.
Okay. Now if we have integral cos cube x dx, one thing is you try to find putting n is equal to 3 into the reduction formula. If you do not want to apply the reduction formula, or if you do not remember the reduction formula, then it does not mean that you cannot solve this kind of questions. You can always do some other techniques to solve this kind of question. For example, I can write this guy as the product of cos square and cos dx, and furthermore I know that cos square is equal to 1 minus sine square into cos dx. So now I have made successfully two expressions. You can try the product rule, or you can try the substitution. If we try the substitution here, if I assume that, let's suppose u is equal to sine x, then what will be du? Du will be cos x dx. In that case, I'm not talking about the integration by parts. I'm simply talking about the substitution. You can directly solve them here, but if you put the substitutions like this, then you see what will happen here. It will become 1 minus sine square means u square, and this whole guy is equal to du. So you have changed the variable. In integration by parts, we do not change the variables. We just separate them for our clarification, but we use the same things again in there. But here I have changed the variable from x to u. So it means I have used the substitution rule. And now this is a very simple integral, and it becomes du minus u square du. And you know how to solve it. It is u minus u cube by 3 plus c, but u is equal to sine x. So it means it is sine x minus sine cube x by 3 plus c. This is the answer. So it does not mean that if you have a sine or cos function in terms of the power and you are bound to apply the reduction formula. No. If you do not remember the reduction formula, you can apply any other technique. You can apply the integration by parts. You can apply the substitution rule. You can apply any technique which you know better than reduction formula. Yes, someone was saying something. For example, another question is, if we have integral sine raised to the power 5x and cos square x dx. Now I can write, look, this is 5, and if I want to make it a perfect square of something, I need to have an even power. So I can write it as sine raised to the power 4x, and 1 sine x I separated here, and the cos square x, this one, and the dx. So I just separated some terms. Now I can write it as in terms of sine square x whole square, sine square whole square, so they are same, and sine x and cos square x and dx. Now look, I know that sine square is equal to 1 minus cos square, so I can use 1 minus cos square whole square, this 1 minus cos square for this, and the whole square here, into, let me write it here, so it becomes cos square x, and keep this there, it becomes sine x dx. Now if I assume this guy as u, the simple cos x, if I assume cos x is equal to u, then du will be sine x dx. So it means I have already this guy, so I can replace this substitution here. It becomes 1 minus, this is u square and a whole square. Again, this is cos square. I know that cos is equal to u, so it becomes u square. And this thing is equal to du. So I have successfully changed the variable from x to u. Everything is in u. Now I can open the square formula and then multiply them together. So it will become u square minus 2u for, I am directly multiplying. First I have opened the square formula and then I am multiplying it with u square. So I am writing the terms directly. And plus u square 4 and maybe u raised to the power 8 into du. Now it is very simple. It will become u cube by 3 minus 2u 5 by 5 plus u 9 by 9. Now you know that u is equal to cos, so you can go back to the original thing. So it will become cos cube x by 3 minus 2 cos 5x by 5 plus cos 9x by 9 plus a constant of integration. So you can apply a substitution rule, you can apply integration by parts, you can apply any idea which is convenient for you. But the thing is that you have to be careful in all the substitutions. There are some other examples solved on the pages. I'm not going to do it, though you can read them. I have done them by hand. Now I'm going to write some important tips for you. And the tips are, what are you doing? Don't send. No need to send anything.
I have a sign problem, like plus minus with the outside and term. Other
Okay.
thing is open.
I have already done it on the pages, so you can check it and compare your answer and you can find out the mistake. Strategy, if you have things in terms of like this, if you have integral a power of sine and multiplied with a power of cos, if you have expressions like this, m and n they could be same or they could be different. For example, you can have sine square x, cos square x dx. In that case, m and n both equal to 2. Or you can have m is equal to 3 and n is equal to 5, suppose. So it will be integral sine 3x cos 5x dx. So m and means they could be same or they could be different, but since one guy is used for sine, so we are using the second number, different number for the cos. Now, if the power of cos, which is n, if n is an odd power, whatever the power of sine is, but if the power of cos is odd, like 2k plus 1, we use this expression in mathematics to represent an odd number. You know, if you have 2k for any k from 0, 1, 2, 3, so on, from 1, 2, 3, so on, 2k means you will have an even number. If you pick up the value of k1, so it will be 2 into 1, 2. If you pick up 2, it will become 2 into 2, 4. 2 into 3, 6. So you will have even numbers. So to represent even numbers in general in mathematics, we write it as 2k plus 1, simply 2k. And if we want to represent an odd number, then we can always add 1 into the numbers and it becomes odd. Because 2k is giving me, 2k will always give you an even number. And when you add 1 into it, the first one becomes 3, this becomes 5, this becomes 7, and so on. So it becomes a list of all the odd numbers. So this guy represents an odd number and this guy represents an even number. Now, if we have the power of, if we have this kind of expression, sine and cos are multiplied, for the moment, forget about the power of sine, focus on cos, and if the power of cos is odd number, 3, 5, 7, 9, any odd number, then make two factors of the cos function, save one factor and represent the other factor, other remaining power as square of cos. I told you if the power of cos is an odd number. For example, in simple case, if the power of cos is 5. So if I have cos raised to the power 5, then I can write it as cos raised to the power 4 into a cos with the dx. Now, this statement says save one factor. I have saved one factor with this. Forget it, save it there. Now, make this guy as a square of cos. And in this square of cos, you can replace this cos square with 1 minus sine square. And when you do that, replacing the 1 minus sine square, now you can assume u is equal to sine x. Just like we did an example just moments before. So you can, if the power is odd number, pick up one factor and keep it there. The remaining will become an even number, whether it is 2, 4, 6, any. Because actually the power of cos is odd number. For example, if it is 5, when I pick up one cos, the remaining is cos 4. And it is an even number. Cos 4 can be written as cos square raised to the power 2. Now, because I know something for cos square, and that something is this one. So when you replace this one, now what will happen? You will have some expressions. This is already in terms of sine, whatever the power of sine is. And this guy will be reduced into cos square raised to the power something, let's suppose k, into one factor which I have pulled out of these n terms, this which I have saved according to the statement, together with dx. Now this is multiplied with this, so this for I know something for this cos square. So I can write it as sine raised to the power mx. This cos square can be written as 1 minus sine square and whole power whatever it is. It is a into cos x dx. Now I can apply substitution on this guy. So I can substitute u is equal to sine x. When I will substitute the u is equal to sine x, this will become u raised to the power m, and this will become 1 minus u square raised to the power k. K is any number, 2, 3, any number, into this is actually the derivative of this. So this will become du cos x dx. So this will become du. So you see, everything we can reduce in terms of u. If you have this kind of expression, moment before we have solved one question similar to it. But now we are talking about the general pattern for doing such kind of stuff. If instead of cos, if the power of sine is an odd number, instead of this guy, if sine is having some power which is an odd number, 2k plus 1, then do the same thing with sine and keep the cos. Means save one factor from this sine here. So one factor will go there. It will become sine. If the power is m 2k plus 1. So the remaining will be 2k. One factor, this plus 1, one factor I have taken out with the dx. And this cos nx already here. Now this guy can be written as sine square raised to the power k cos nx, I don't care, sine x dx. I know something about sine square, and sine square is equal to 1 minus cos square. So I can replace it, and so it will become 1 minus cos square raised to the power k and cos n and sine x dx. Now I can use this substitution. So I can substitute u is equal to this person, the cos x, and the derivative will be du is equal to sine x dx. So this is here, and it will become 1 minus u square raised to the power k, whatever it is, and this will become u raised to the power n, and this will become du. So we have converted everything into u, and you can solve this integral. This is simply a power rule of the integration. So if you have this kind of situation, you can apply these two rules. And sometimes if you have the same powers of both sine and cos, if for example, if this is 3 and this is also 3, means m is equal to n, both the powers of these two functions are same, then you can use the half angle inequality. And the half angle inequality is, you can always replace sine square x is equal to not equal. Instead of equal, and we are talking about even. If both are even, then you can replace m is equal to n is equal to, they are even numbers, some 2, 4, 6, 7, 8. So you always know the inequality, the half angle inequality for the sine and cos. For sine it is 1 by 2, 1 minus cos 2x, and for cos the half angle inequality is 1 by 2, 1 plus cos 2x. So you can replace, you can make it, for example, if both are even, then they will be like this: sine raised to the power 2kx, cos raised to the power 2kx dx, because they are the even numbers, m and n. So they will be sine square raised to the power k, cos square raised to the power k, and a dx. Now you know something about these guys. So you can put these inequalities there. So it will become 1 minus cos 2x whole power k and 1 plus cos 2x whole power k divided by 2, whatever it is, and then you can simplify them. You can always use the half angle inequalities if both are even. Now, okay. Now, similarly, if you have, instead of sine and cos, if you are dealing with the tan and secant, and you have a product of tan and secant, to deal with such cases, tan mx and multiplied with secant raised to the power nx dx. If you have this kind of situation and the power of secant n is some even number 2k, then do the same. Save one factor, pick up one factor out of this whole sign. For example, if it is sine 4x, then pick up one factor there and the remaining will become pick up one factor of secant square, not the simple secant, because we are actually trying to find something which will make this thing secant square x dx, and we know something has a derivative this guy. You will see that what we will substitute. We have the problem when we will do the substitutions, we have to take care of this derivative. If we do not successfully find this derivative, this term as a du, then our substitution fails. So we always take substitution such that du should be equal to the leftover part. So here, in this case, if this guy is an even number, then take 1 sine square, one factor, keep it safe, and the remaining will be integral tan mx, I don't care at the moment, and this guy will become secant n minus 2 x into 1 secant square is there and dx. If this is, yeah, so if it is n minus 2 and I already told you that n is equal to 2k, so it will be actually 2k minus 2. So it means it will become tan m of x, and take the common 2, so it will become secant square x raised to the power k minus 1 into 1 secant square x, you already taken there. Do you understand what's happened here? If this guy, if at the moment we are talking about n, so we don't care about this term. If this is tan mx, but this power is even number, means if this is 2k x dx, now pick up 1 secant square from here and keep it with the dx here. I kept it there. Now when I will pick up 1 secant square out of the 2k secant squares, the remaining will be 2k minus 2, because I have taken 1 times 2 there, so it becomes 2k minus 2. And when I take 2 as a common inside, the outside is k minus 1. Now secant square x, you can, do you know what is secant square x equal to? Just like we said that cos square is equal to 1 minus sine square, and sine square is equal to 1 minus cos square, then secant square is equal to what? Anybody? One plus tan square. So now we are making something in terms of tan. So it will become tan raised to the power mx into secant square. I know it is equal to 1 plus tan square. So it will become 1 plus 10 square x raised to power k minus 1, whatever it is, into 1 secant square x dx. So now I have this guy, these terms in terms of 10. So I can assume something like this as u. I can assume u equal to 10x. When I will assume u equal to 10x, then du will be, you know that the derivative of 10x is secant square x dx. And this I needed for du. I already have saved this thing. So it will become integral u power m, this guy, into 1 plus u square raised to the power k minus 1 into this whole thing is equal to du. So we have substituted, we successfully converted the variable in terms of u. Now you can solve this integral, simple power rule. And if instead of n, if the power of 10 m is something like 2k plus 1, then save one factor of secant x 10x so that you can later on make the derivative equal to it. So similar pattern, but save one factor of the 10 and secant for this guy. For this guy, keep the secant, keep the 10, because when you will put the substitution, now we are talking about this and we are trying to convert this in terms of secant. So ultimately, we will have something in terms of secant. So we are going to make the substitution in terms of secant x. And when you make the substitution in terms of secant x, the du will be secant x 10x. The derivative of secant x is secant x 10x. So it means you need this thing at the end. So how you can get this thing? Pick up one secant from here and one 10 from here and keep them safe. Don't do anything with them. Secant x 10x dx. Now whatever is remaining with you here and here, keep it safe, but this guy, convert this into the secant x and then ultimately use this substitution and you are done. Let us do two examples to see whether these results are successful or not. If we have integral tan 6x secant 4x dx. Now you see, I told you that if the power of secant is even number, this guy was n and I said if n is equal to 2k, some even number, then pick up one secant square out of it and keep it there with dx. Like 1 secant square from this 4, I am going to keep it with dx. So what is remaining? The remaining is secant square x into exactly tan 6x. Now I know that this is tan 6x and secant square is equal to 1 plus tan square. And this I have already saved. I'm not going to do anything with it. Now I have this whole thing in terms of 10 and this thing is separated, which I am not going to touch. So in this whole thing, if whole thing is about 10, then I can substitute tan x is equal to u. Then du will be secant square x dx. So I can put these values there. It becomes u power 6 into 1 plus u power 2 into this whole thing is equal to du. And you can solve this integral. It will be u power 6 plus u power 8 integral du, and it will be u power 7 by 7 plus u power 9 by 9 plus c, but u is equal to tan x, so it will be tan 7x by 7 plus tan 9x by 9 plus c. Okay. Now another question from the same. For the sine cos, we already done the questions and then we wrote that formula. For the tan secant, we are doing the questions now. One question for this even power, we have done it. Now the second question, if the power of tan is an odd number. So if we have something like tan 5 theta secant 7 theta d theta. Now in this case we said if this power is odd, so we can see that m is 5, which is an odd number. So we said pick up one secant and one tan from both of them and keep them same with the d theta. So with d theta I have secant theta, tan theta, and I pick these two from there. So what is left over? One tan is gone, so it is tan 4, and one secant is gone there, so it is secant 6, and this guy. Now this can be written as integral tan, what will be the substitution? Secant theta. So we have to convert this whole thing in terms of secant. I know that tan 4 theta is equal to tan 4 theta can be written as tan square theta raised to the power 2 into secant 6 theta into this guy, which I am not going to touch, tan theta d theta. Now I told you that secant square is equal to 1 plus tan square. It means tan square is equal to 1 minus secant square, right? This we know, so we can write this. So it means I can replace tan square with this, so it becomes 1 minus secant square theta whole square into secant power 6 theta into this guy secant theta tan theta d theta. Now this whole expression is in terms of secant, so I can assume u is equal to secant theta. Then du will be secant theta tan theta d theta. So this whole thing is replaced with du, and these guys are replaced with 1 minus secant theta is u, so 1 minus u square raised to the power this 2 into u power 6 and a du. This whole thing is equal to du. Now simply multiply them and apply the power rule of integration and you are done.